Alright guys, Mr. Murphy here, and I'm bringing you the first ever video lesson for our class. This is going to be stuff we've already covered for you, so this shouldn't be anything new, but just wanted to review a little bit to give you something to look at as a resource while you're working on assignment number 1, particularly questions number 1 through 6, which I will make sure to make note for every one of these lesson videos I do. This one is about central angles and arcs. So, important thing to remember with central angles, they are at the center of the circle. So this angle right here is 70 degrees. That's a central angle. Remember that the measure of an arc in degrees is determined by the measure of its central angle. So if I want to know the measure of this arc out here, I just got to know, hey, the angle right here is 70 degrees. Therefore, the arc is also 70 degrees. Make sure you write that on the outside of the circle. Cool. So, in short, central angle equals arc. Cool. Now, when you're solving for unknown angles or unknown arcs using this central angle relationship, there are a few different tricks that you can use. I'm going to go over those in the 3 examples you see below. But the important thing to remember is that central angle equals arc. Another important thing to remember is that whole circle is worth 360 degrees. Those are the 2 main things to know when you're doing central angles. Okay, here we go. Cool, I'm going to scroll down a little bit. Question number 1. We're going to solve for the measure of angle QPR using this circle down here. Cool. Now, the first thing I notice is that I have this arc out here, which is worth 75 degrees of the circle. That's the measure of arc ST. Now, if I know that my central angle is equal to the arc, I just find the central angle that intercepts this arc, which would be angle TPS, and I know that those measures are equal. So I'm going to go ahead and put 75 degrees right there. Cool. Now, the angle we wanted was angle QPR. I'm going to mark that one now. Point QPR right here. Cool. Now, how do I solve for this angle if the only angle and arc that I know are over here? Well, if you notice, this line is a diameter, goes straight through the center, and this line, TR, is also a diameter. So we have 2 intersecting straight lines. And what do we call angles that are opposite each other on straight lines? We call those vertical angles. And what do we know about vertical angles? They're always equal to each other. So we can use vertical angles on the insides of circles to help us solve problems. So if I know that vertical angles are always equal, and I know that this angle is 75 degrees, I also know that our angle is 75 degrees. That would be our answer. Cool. Alright, so this is the first trick you want to make sure you keep in mind when doing central angles and arcs, is to look out for those vertical angles. Now that's just one possibility that you may run across. I picked out 2 other problems to demonstrate a couple other possibilities. So, moving on to question number 2. We are solving for the measure of arc IJ. I'm going to go ahead and mark that arc now. So here's point I, here's point J. I want to know how many degrees that arc there is worth. Cool. Now, I want to look for things I already have to help me out, because I can figure out central angles using arcs, I can figure out arcs using central angles, and I know the whole circle is 360 degrees. Now, if the whole circle is 360 degrees, another thing to look out for are half circles. Because if a whole circle is worth 360 degrees, then a half of a circle or a semicircle must be worth half of that. And 360 over 2, or 1/2 of 360, would be 180. Now if I check this out and look at line GJ, line segment GJ is a diameter, so it splits the circle in half. I know this arc is 96 degrees. I have a 41 degree angle here, which means a 41-degree arc. 96 plus 41, that's going to be 7. 9 plus 4 is 13, so 137. Which means our arc must add to that to equal 180. So quick little calculation, 180 minus 137, that's going to be 10 minus 7, change that to a 7, 7 minus 3 gives me 4, and the 1 minus 1 cancels out. So the answer here will be 43 degrees. Because if I take 96 plus 41 plus 43, it adds up to that half of a circle, that 180 degrees. Cool. So remember, diameters split your circle in half. So I'm going to write, look for half circles. So 2 strategies. Vertical angles, look for those half circles. All right, cool. Number 3, we're going to solve for the measure of angle HJF. So angle HJF, start at H, straight line to point J, straight line to point F, so this angle. Cool. Now if we look, we can see that we have a 60-degree angle right here. Let me write that again because I kind of wrote over it. It should say 60 degrees. And then a 40-degree angle inside of angle FJG. Cool. Now hopefully instinct takes over here. When you see 2 angles inside of a larger angle, don't forget that angles add together. Angles add together. This is also true of arcs. So if you're solving for an arc that has 2 arcs inside of it, arcs also add together. Okay, so this one should be pretty easy. We take those 2 angles, add them up. So 60 plus 40 gives you 100, which means the measure of angle HJF should be equal to 100 degrees. Cool. And that is how you use central angles to find measures of missing angles or arcs. Knowing how to do this is very useful when you are trying to do things like sector area or arc length, which will probably be my next video. So be on the lookout for that. All right, just to recap before I end the video. Central angles are equal to their arcs. Whole circle is worth 360 degrees. Half circles are worth 180 degrees. And then the things you want to look out for, places where you can set vertical angles equal to each other. That looks like this. Look out for those half circles, like this. Now notice there was also another diameter here, just pointing that out. Okay, and then last but not least, remember that angles can be added together and arcs can be added together. That can often help you when you're trying to finish up those half circles or those whole circles. Okay? Cool. I'm going to go ahead and end this and post it. If you guys have questions on it, the best time to ask me those questions will be during those Zoom office hours. If you don't get to me during that time, or you still have a question later on or something like that, best thing to do is probably send me an Edsby message. If I don't get back to you for whatever reason, just look for that Google Voice number and give me a call.